Guys, and welcome to Science Academy. So today we will be discussing about some measuring instruments, right? Some measuring devices, measuring instruments. So that's what we are going to discuss. And before starting the topic, let me give a brief introduction that this video has not just made for the NEET or JEE aspirants. So this can be used for the any of the grad level students, the undergrad level students, and anyone who really just want to know about basically the instruments used in physics, the very basic instruments, right? And any high school students, obviously, right? Okay, and of course, NEET and JEE aspirants. So, guys, let's discuss the topic. So today's topic, what I'm going to discuss is about screw gauge. So screw gauge is an instrument which is familiar to most of the science students, at least the people who are connected to the lab. Obviously, they'll be knowing, the physics lab, right? So yes, today's topic is basically the structure, the working, and something called as the least count of screw gauge. I will try to, I will just try my level best to make you understand the concept as simple as possible. So first of all, we will discuss what is a screw gauge. We'll just go through the definition of it, like how it is and all. So screw gauge again. So screw gauge is basically, screw. Obviously, something that twisted thing. It moves kind of. So gauge is something like uh, a device which measures as well as it displays. So those quantities we can call that, oh, sorry, that devices we can call that as a gauge, right? So screw gauge is something, right? So imagine you're having a meter scale, right? A meter scale. So in a meter scale, if you see by your naked eyes, you could see only 1 mm, right? 1 mm you can see. So if you use a device called as a vernier calipers, what you could see is 1 by 10th of an mm, you can see, right? Or you can decimally write it as 0.1 mm is what you can see, like using your naked eyes, or what you can measure, I'm sorry, what you can measure. So, and a screw gauge, we can measure the 1 by 100th of an mm, which is basically 0.01 mm, right? From this we can understand that meter scale, vernier caliper, and screw gauge. So here what we can understand is that this is precise. Obviously, I'm not saying that it's not so precise, but yeah, this is more accurate. This is the most accurate. When the things which we can see here, right, is the least measurements which we can take. The measurements, the values when it is very less, very low, we can say the instrument is going to be more precise, or when the device is going to be more precise. That's what we can say, huh? So now just can we just go back to the construction part? I'm going to explain it. Let's see that. So here, this is the kind of structure for a screw gauge. I'll explain it. So this is kind of a structure that it is actually having here, kind of like this. Okay. And here, if you could see, here there's this, this screw kind of thing is there. It's kind of twisted, right? Like this, huh? And there you can see some measurements over here. So this measurement, which you can see, it has a name which is circular scale, the circular scale, and this is actually the screw. That's why it got the name screw gauge, which you can understand actually. Then this is right-handed screw, right-handed screw, fine. And this is spindle, right? Now, guys, what is this right-handed thing? Now, for example, you're taking your right hand, right? Your right hand, and you just imagine. I'm a terrible person when it comes to drawing stuff, so please bear with me for the sake of the class, right? So your right hand, and you're just curling this, curl your fingers, all the four fingers except the thumb, in let's say in this way, right here in the anti-clockwise direction. When you like curl it, the direction in which the thumb gives, this is actually the direction of the spindle, right? So this is a right-handed screw. Clear? So when you rotate this circular scale part in the anti-clockwise direction, right, what happens to the spindle? It moves forward, right? So what if you are rotating it in the clockwise direction? The spindle will move backward, right? But there is no rocket science behind it. It's actually easy. So yeah, so that's the part. Now we will go to the actual figure of screw gauge, right? So the actual figure of screw gauges, we have something like um, this shape, a U kind of shape. Yes, right? Yeah. And we have something like this here, and something over here, and we have this thing here, and from this part, this is not a perfect figure, and I'm not a perfect artist, so just yeah, it's not a proper diagram. That's I'm just kind of making you guys understand in a possible way. Like, yes, okay, خلاص. So yes, guys. So this, what which you can see here, this one. This is a fixed metallic frame. It's a fixed metallic frame kind of thing, huh? And what you could see here, like this, right? This is a um, this is actually the main scale, right? And about this is the part where you can actually see the screw, right? The screw which you have seen over here, let's say uh, the screw, where is it? Yes, yeah. Now listen. So guys, this this screw, this is get covered by something which is called as a sleeve, right? So that the screw is not exposed. So this sleeve has marking on it, right? So that sleeve is what you're seeing here. So this is the sleeve, and this is the main scale. So as I have mentioned that this is our circular scale. That's the circular scale, right? And this is a fixed jaw, fixed jaw. And this part which you can see is the spindle which you have seen here. This spindle and this spindle are same, right? So this is a spindle, and this is a movable jaw, right? So yes, that's it. So this is a circular scale, this is the main scale. So we got almost all the components that is required for understanding the you know screw gauge. So let's start discussion. So now you know how it goes and how it works in particular. So guys, now let's discuss on how we measure, right? So first of all, I just want to mention about the thing called as least count. But before going to that, I want to mention two, three other things. Guys, listen. So here you can see that this portion which you are seeing, right? This has been divided into 100 equal divisions. 100 equal divisions, right? So that being said, we can just move to next, yes, least count. So least count, I'm going to, before this going into the least count, just wanna mention what is meant by pitch. So these are the terms which you might come across when you go through these measuring devices. So pitch, it basically means that the you know in one single rotation of the this where is it, yeah, my circular scale, in one single rotation of my circular scale, by how much distance. So let's consider that this is my circular scale, and this circular scale I'm rotating it in anti-clockwise direction. So when I rotate it, right, this part you can see, right, this, it will move forward, am I right? So when that move forward, what is that distance in one single rotation, in one rotation of the circular scale, right? By what distance the circular scale move forward, or we can say even what is the distance that the circular scale covered in the main scale, right? As you know that this is the main scale, so that main scale, so that is what we actually call as pitch. So when we discuss in detail, or when we sorry, yeah, when we understand this, we can understand that. So when one rotation happens, right, when one particular rotation happens, so technically when we analyze the situation rather than just merely thinking about the theory part, right, I'm going to take an example so that you will understand that better, right? Just for example, let's say in one rotation of my circular scale, just when I rotate my circular scale once, what I'm getting is 1 mm is the distance it has moved. So let me explain that again. Yes, yeah. So this is my circular scale. So when this circular scale has rotated by one rotation, what happened is here this thing has moved by 1 mm in the main scale. So one rotation is equal to 1 mm. I can write one rotation of the circular scale. So the 1 mm is what the circular scale moved or displaced in the main scale. So yeah, so one rotation, as I mentioned, that in circular scale, how many parts are there? There are 100 parts, am I right? 100 such parts. So this part will also move one rotation. This part will also move a rotation. This part will also move a rotation. Likewise the 100 parts, the 100 parts, and those 100 parts are actually equal. So those 100 equal parts, so all of that thing rotates, and that is gonna create a movement of 1 mm in the main scale, right? So the movement of one part, for one part when it rotates, so it is going to be this 100, you have take to the other side, the denominator, 1 by 100 mm. So this is basically what you could measure in a screw gauge, right? So let's put this thing in equation. So the least count, we can see that it is the pitch upon the number of divisions on the circular scale. So if you see this, so least count is pitch. So as I mentioned that, what is a pitch? In one rotation, what is the distance that it covers, right? So can I say that it is 1 mm? Because it is 1 mm, right? Because that's what I've assumed. So 1 mm upon. Now, the number of divisions on the circular scale is 100, that we know, right? So what is the least count here? 1 by 100 mm. That's it. This is the least count of a screw gauge, right? That's it. Now we are gonna know what is the what is the thing in measurement when it comes to what are errors and all those things. So if you want to find the readings, right? If you want to just find the readings, what you have to do is that the total reading is equal to the main scale reading plus the least count times the circular scale reading. So this will give you the proper complete reading in case of screw gauge. And similarly, when you look at the type of errors, so guys, the type of errors, if you want me to explain, I could explain that. But before that, let me just give an example on how this works. So let's say this is my screw gauge, right? And let's say I just kept something over here. I have to find the diameter of that thing. So it's not a perfect diagram, as you know. Yeah. So what happened over here is that, let's say this here, we can see that when you rotated this circular scale and all, what you got, you got this as 7 mm, right? And this I'm gonna a little bit draw it here. Okay. What you can see here is, let's say the 46 division somehow merged with this main scale reading over here. What you can see that when you find, if they ask you to find what is the diameter of the total reading, when they ask you to find, you can find it by, what's the formula, MSR plus LC times CSR, right? So you do that, what you get is MSR main scale reading is 7 mm plus, the least count is 1 by 100 times the CSR, let's say it's 46. So you're going to get, this is also mm, obviously. So 7 mm plus 0.46 mm, that's going to be 7.46 mm. So this is going to be your reading, right? So based on the number of readings you do, the number of times you want to repeat the experiment, you'll get more accurate answer. This one is accurate though. So now let me discuss a little bit about errors, right? Errors. So guys, you know that what errors are. I'm gonna make it simple as much as possible for you to understand. So let's go back to the figure. Where's my figure? Sorry for that. Where's my figure? Yeah, let me place it back there. Yes. Yeah. So listen. So guys, when you see here, um, when we rotate this circular scale and it moves forward and forward and forward and forward and forward, and when these two meet, actually when they are close together, and this zero line over here, the zero line over here, and this main scale, if they are in the same line, we can say that there is no zero error. There is no zero error, right? So yes, that's that I want to just mention it. Yeah. So when there are errors, so first of all, what is this error thing? Let's say you have a meter scale. It's a pretty small meter scale, or maybe a big one. I think the big one is fine. So what happened? It's broken. It's broken. So you got a broken ruler, right? And you want to measure the length of a road or something, kind of a road, and it's broken from 10 centimeter, right? Up to 10 centimeter it was broken. And when you have measured, you got the value as 80 centimeters, right? So actually, can you write that the length of this road is 80 centimeter? Can you write that? You can't. Why? Because there is an error. So what is the error there? The error is actually positive 10. The error is actually positive 10, which means that your actual value is supposed to be 10 less than the value you got, right? So when you do the correction, so yeah, this type of errors, you can call that as positive error, right? But when you do the correction, what do you have to do? From the measured value, you have to subtract it minus the error you get. If the error is positive, from the measured value you have to subtract it. You got my point, right? Because actually the value should be, measured value is 80 minus the error, the positive error is 10, so it's going to be 70, because 70 centimeter is the actual length of the road, right? So similarly, let's consider that you have um, yeah, you have another ruler or a meter scale, or something, not a meter scale, sorry, another ruler, and it is like, you know, kind of the zero starts from here, and it's 10 centimeter extra is there, the same road, right? Another kind of a road, another road, and you have measured, so an example, yeah, you have measured the length and you got it as 80 centimeter. Here when you write the measured length is not your actual length. Measured length, if you write it as 80 centimeter, you can't say that is the actual length. No, that's not. Why? Because there is an error, right? There's an error. What is that error? This error is what we call as negative error. So negative error means it's actually minus 10 centimeter, because extra of a 10 centimeter is there, right? So when you do the correction, what do you get? The measured value plus the error will give you the answer. So what is the measured value? 80 plus, it's not negative, plus 10, it will give you 90 centimeters. This is the actual length of the rope, right? So whenever the error is positive, I repeat, when the error is positive, right, you have to from the measured value, the real value is equal to the measured value minus the error, and when the error is negative, right, the real value is equal to the measured value plus error. Right, now let's discuss about um, the screw gauge. So what are the different types of, errors in case of screw gauge? That's the topic I'm just mentioning. So let's say that this is a reference line I have, and this is our circular scale, that thing border. If the zero is below it, right, when we rotate in a clockwise way, and you're getting the zero is below the this reference line, you can say that the error for the screw gauge is positive zero error. If this, when you rotate it, and if the zero was, let's say this zero, you can see, if the zero was over here, you can say that there is no zero error, right? Since it is over here, there is an issue, so it is positive zero error. So when you do the correction, so whatever the value you're getting, right, the measured value, right, minus the error will give you the actual answer or the actual reading. Similarly, you have this reference line and you have this main scale and the reference line, right? And when you, okay, you're rotating clockwise and the zero is here, right? Again, what's the situation if the zero was over here? When the zero was over here, this is known as no zero error. Since the zero is over here, there is some errors, some errors there, right? This one. So this is what we call as the error should be negative, zero error. When it is negative zero error, what is the correction which we have to do? That is, the real value is equal to the measured value plus the zero error. So I hope you understood the contents which we have discussed today. This is actually the total content that we have discussed and in today's lecture, actually, kind of pretty much, yeah, I hope you can see that. So thank you so much, guys. This is the content that we have actually discussed, and thank you so much for listening. So if you have any doubts, please ask in the comment. You can just comment whatever the doubts you're having, and please subscribe the channel and share and like, and because your support is necessarily required uh, for the channel, to move forward in the long journey. So I will try to make the videos, informative videos and all, as much as I can. So keep learning, happy learning, guys, and see you, and thank you.